Hi all, I am Sidheek from Mechanical Department of Rajagiri School of Engineering and Technology. In this lecture, we will be discussing the topic from section of solids. To explain the concept of section of solid, let us consider the example of a square pyramid. As you know, a solid is a three-dimensional object having length, width and height. So here, if you observe the square pyramid, you can see only the exterior details of the solid. It has 4 base edges, 4 slant edges and 4 triangular faces, and at the base you have a square face. So if you observe the solid, you can see only these exterior details. But if you want to see the interior details of the solid, if you want to see what is inside the square pyramid, then it is assumed that the square pyramid is cut by a section plane and the portion of the solid between the object and the observer is removed. Now let us consider this case. So here the square pyramid, it is resting on horizontal plane on its base and it is cut by a plane parallel to its base. So this is the section plane, it cuts the square pyramid and it is parallel to the base. Now here we assume that the portion of the solid between the section plane and the observer is removed. So here you can see that the top portion is removed from the square pyramid. Now in the remaining portion of the solid, you can see the surface through which the section plane has passed. Now this surface is called the section of square pyramid. So simply a section means the surface through which the section plane has passed through the solid. Now we have come across a few terms in this topic. First one is section plane. It is also called cutting plane or auxiliary plane, or the section plane. So here this is the section plane which is parallel to the horizontal plane. Now the next term is sectional views. So if you consider the top view of the object which is cut by the section plane, it is called the sectional top view. Similarly, if you cut the solid using a section plane which is parallel to VP. So in the previous case it was parallel to HP. So instead of having a plane which is parallel to HP, if you use a plane which is parallel to VP and perpendicular to HP, you can remove some portion of the square pyramid from the front side. And if you observe the solid from the front side, you can see the sectional front view of the solid. Similarly, you can remove some portion from the side also using a plane which is perpendicular to HP and perpendicular to VP. So that if you observe the solid from the side, you can see the sectional side view of the solid. So as we have seen, there are several types of section planes and many sectional views. You can have sectional top view, sectional front view or sectional side view. And another important term is true shape of the section. So in this case, in the previous case where the section plane is parallel to horizontal plane and perpendicular to the vertical plane, in the top view you can see the true shape of the sectioned surface. In order to see the true shape of a surface, the direction of sight, the lines of sight or the projectors which are originating from the eye of the observer, they should be perpendicular to the surface. So in this case, if you observe the object from the top, you can see the true shape of the section because the lines of sight are perpendicular to the surface. In some other cases where the section plane is inclined to HP and perpendicular to VP. So we consider a section plane which is inclined to HP and perpendicular to VP. In this case, after removing the portion of the solid between the section plane and the observer, if you look at the solid from the top, you cannot see the true shape of the section. Instead, you will be seeing an apparent shape. You cannot see the true shape, you will be seeing a false shape. This is called the apparent shape. And to see the true shape of the section, the direction of view should be made perpendicular to the sectioned surface, or the sectioned surface should be made perpendicular to the direction of view. So these are a few important terms that come across the section of solids. So in the previous section we have seen these many different types of section planes: parallel to HP and perpendicular to VP, parallel to VP, perpendicular to HP, inclined to HP and perpendicular to VP, inclined to VP, perpendicular to HP. Then the last one is perpendicular to both HP and VP. Now this is the case of the section plane which is parallel to HP and perpendicular to VP. Here the solid is cut like this. The cone is, here it is a cone, it is resting on HP, on its base, and it is cut by a section plane like this. So that is the first case. And the second case is the section plane parallel to VP and perpendicular to HP. Here the position of the section plane will be like this. It is perpendicular to HP but parallel to VP, and you can remove some portion of the cone from the front side like this. Now the next case is a section plane inclined to HP and perpendicular to VP. So it will not be no longer parallel to VP, it will be inclined to HP and parallel to VP like this. Now the next case is a section plane which is inclined to VP and perpendicular to HP. So it is the section plane is perpendicular to HP and it is not parallel to VP, it is inclined to VP. So you can remove some portion of the solid from the, not exactly from the front side, from the side of the solid. Next, a section plane perpendicular to both HP and VP. So it will be like this. The section plane is now perpendicular to HP and it is perpendicular to VP also. So here you can see, you can remove some portion of the solid from the side, either from the left side or from the right side. So these are the different types of section planes. Now we will try to solve a problem from this topic. So here a cube of 50 millimeter side, it is resting on HP on a square face with one of its vertical faces inclined 30 degree to VP. Now here the section plane, it is parallel to VP and cuts the cube at a distance of 15 millimeter from the vertical edge nearer to the observer, and you are asked to draw the sectional views. So a cube can be represented like this. You have 4 base corners, namely A, B, C and D, and 4 top face corners 1, 2, 3 and 4. Now the base edges are A, B, B, C, C, D and D, A, and the top face edges are 1, 2, 2, 3, 3, 4 and 4, 1, and there are 4 vertical edges 1A, 2B, 3C and 4D, and there are 4 vertical square faces 1, 2, AB, 2, 3, CB, 3, 4, DC and 4, 1, DA. Similarly, the base is also a square face ABCD, and at the top face also you have a square face 1, 2, 3, 4. Now it is given that the cube is resting on HP on a square face, and one more condition is there, with one of its vertical faces inclined 30 degree to VP. So you can keep any vertical square face inclined to VP by 30 degree at the first stage itself. So we draw the XY line, and you can draw a line inclined 30 degree to XY line. Now we need to draw the top view of the cube. So here it is resting on HP on a square face, so you can see the true shape of the base in the top view only. So you have to draw the top view first. So we draw the cube. In the top view you will be seeing a square face. Now I name the square face, the corners of the base as ABCD like this, and the top face corners are 1, 2, 3, 4. So in the top view you can see 1 in bracket A, that is you will be seeing 1 in the top view, you can see 1 first and then A. So the corner which is at the bottom side is named inside the bracket. Similarly 2B, 3C and 4D. Now we have to draw the front view of the object. So I draw projectors. Now raise the height equal to 50 millimeter. 50 millimeter is the size of the cube. Now name the corners in the front view also. A dash. Here B dash is at the back side, therefore we keep it inside the bracket. Then D dash and C dash. Similarly 1 dash, 2 dash is also at the back side. Then 4 dash and 3 dash. So we have completed the front and top views of the cube. Now we need to introduce the section plane. It is given that the section plane is parallel to VP and it cuts the cube at a distance of 15 millimeter from the vertical edge nearer to the observer. So first of all you have to identify the vertical edge which is nearer to the observer. So when the observer is looking from the front side, which is the vertical edge nearer to the observer, it is 4D. He will be seeing 4D first. So 4D is the vertical edge nearer to the observer. From this edge you have to measure 15 millimeter and introduce the section plane. So I measure 15 millimeter along this projector and mark a point over here. Now I can introduce the section plane. See how I am drawing the section plane in the top view. Normally to represent the section plane we use a thin chain line with thick ends. Chain line means a long dash followed by a short dash, and it should be a thin line, a light line, and the ends of the light line should be thick. So this is how we represent the trace of a section plane. Actually we are drawing the trace of the section plane which is perpendicular to edge P. The next step is you have to identify the cut points. Cut point means the points where a section plane meets a particular edge. So if you consider the edge 1A, if the section plane cuts this edge at a point say P, P is a cut point. Similarly, there can be cut points along the edges 2B, 3C, 4D or AB, BC, CD, etc. They are base edges, whereas 1A, 2B, 3C, etc. are vertical edges. Now here you can see that this section plane passed through the edge 3, 4 as well as CD. So you have to consider two cut points here because the section plane cuts two edges. So we consider the cut points P and Q. So here P is at the top face and Q is at the bottom. So I keep Q inside the bracket. Similarly here also there are two edges being cut by the section plane 4, 1 and AD. So here also you have to consider two cut points. So I name it as R and S. Since S is at the bottom side, I keep it inside the bracket. Now the next step is you have to transfer these cut points into the front view. Now here you can see that the cut point P, it is on the edge 3, 4. Therefore, its front view P dash will be on 3 dash, 4 dash. That is, P is on 3, 4. So its front view P dash will be on 3 dash, 4 dash. So to transfer P to 3 dash, 4 dash, I need to draw a projector from P to 3 dash, 4 dash. So I have already drawn a projector from P to 3 dash, 4 dash. Now I can mark the cut point P dash on 3 dash, 4 dash. Similarly, the cut point which is at the bottom side, it is Q and it is on the edge which is at the bottom side, that is CD. So since we have kept the corners inside the bracket, you can easily identify the edge which is at the bottom side. CD is the bottom edge and the cut point on the bottom edge is the point which is kept inside the bracket which is Q. So draw a projector to C dash, D dash and you can obtain the front view Q dash. Similarly, transfer the cut points R and S to the respective edges at the front view. So here where is R? R is on 1, 4. Therefore, R dash should be on 1 dash, 4 dash. So you draw a projector to 1 dash, 4 dash and mark the point R dash. And where is S? S is on A, D. Therefore, S dash will be on A dash, D dash. And we have this, we can use the same projector. So you can mark the cut point S dash. Now we have identified the front views of all the cut points. Now the next thing that you have to do is simply join these cut points, that is P dash, Q dash, R dash and S dash. So you will be getting a rectangular shape. Now I connect P dash, Q dash and R dash, S dash. Now this is the sectioned surface. P dash, Q dash, R dash, S dash is the sectioned surface of the solid. Now in order to identify the sectioned surface, we use the hatching lines. Hatching lines. Now the property of hatching lines is that there should be light lines. There should be light lines and they should be inclined to the horizontal plane by approximately 45 degree. You can use 30 degree lines or 45 degree lines. So there should be light lines and they should be equally spaced. So it will be like this. You have to use light lines and using equally spaced lines which are inclined to the reference line, to the XY line by an angle, say 45 degree or 30 degree, you can draw the hatching lines. So this is the hatched surface, this is the sectioned surface where I need to draw the hatching lines. They should be light lines and equally spaced, inclined to XY line approximately by 45 degree. So this is the sectioned surface. Now one thing you have to keep it in mind that in section of solids we use a section plane in order to cut the solid, and the portion of the solid between the observer and the object is being removed. We assume that the portion between the section plane and the observer is removed. Hence the portion which is removed should be retained in the solid using light lines. So initially when you draw the cube in the top view, you should use light lines as far as possible, and after introducing the cutting plane, the portion, here you can see that this is the cutting plane and the observer is looking from this side. Now this is the portion between the section plane and the observer. So that portion which is being removed from the solid should be retained using light lines. So this should be light line. So the easiest way to make this drawing is initially when you draw the object, it should be drawn using light lines, and after introducing the section plane and identifying the cut points, you can make the remaining portion which is retained on the solid, you can make those portion dark. That is, only this much portion will be dark. So everything in front of this will be retained as light lines. So now you can mark all the dimensions. So that is the solution to this problem. Now we will see another problem. Here it is a pentagonal pyramid of base edge 30 mm and height 60 mm. It is resting on HP on its base with a base edge parallel to VP. An auxiliary plane, here see the term auxiliary plane. You may not be getting the same term cutting plane or section plane in the questions. You may also see this term auxiliary plane, auxiliary inclined plane, or simply auxiliary plane. So here an auxiliary plane perpendicular to VP and inclined 45 degree to HP passes through the axis at a height of 35 mm above the base, and draw the sectional views. Also you have to draw the true shape of the section. In the previous question it was not asked to draw the true shape of the section. Why? The reason is that the section plane was parallel to the base or parallel to HP and the section plane was perpendicular to HP and parallel to VP. So in the front view itself you can see the true shape of the section. So it is not separately asked. But here the section plane is, the auxiliary inclined plane is inclined to HP by 45 degree and it is perpendicular to VP. So here first you have to draw the orthographic projections of the solid in the given position. So here first you have to draw the orthographic projections of the pentagonal pyramid. It is resting on HP on its base. So here also you can see the true shape of the base in the top view. So you have to begin with the top view of the pentagonal pyramid. And there is one more condition. one of the base edges is parallel to VP. So you have to start drawing by drawing one base edge parallel to the XY line. So you start from here. Now I mark the corners A, B, C, D and E. There are 5 base corners and an apex O. So this is the top view of the pentagonal pyramid. Now to draw the front view, I draw projectors from each of these corners. So this is A dash, B dash, C dash, D dash and E dash. Here B dash and C dash, they are at the back side, so it would be better if you keep it inside the bracket so that you can easily identify the points which are at the back side. Now extend the axis and mark the point O dash. It is the front view of the apex. So I have drawn the front and top views of the pentagonal pyramid in the given position. Now I have to introduce the section plane. It is given that the section plane or auxiliary plane is perpendicular to VP and inclined 45 degree to HP, and it passes through the point on the axis 35 mm from the base. So first of all I have to identify this point 35 mm above the base. I have to identify a point. So measure 35 mm. The total height is given to be 60. So measure 35 from the base and mark the point. Now through this point I need to draw the section plane which is inclined to HP by 45 degree. So at an angle of 45 degree you need to draw the section plane. This angle is 45 degree. So I have introduced the section plane. Now I need to identify the cut points. So for this you have to see how many edges are being cut by the section plane. So here you can see that there are 5 slant edges for a pentagonal pyramid and all the 5 slant edges are being cut by the section plane. So let us start from the left side. Here there is a slant edge O dash D dash. It is being cut by the section plane. So you have to identify a cut point P dash here, and next is O dash E dash. It is O dash C dash. It is also being cut by the section plane. So Q dash, and at this position over here the slant edge O dash E dash is being cut. So R dash, then here S dash, and here T dash. So we identified the 5 cut points over the 5 slant edges. Now what is the next step? You need to transfer these cut points onto the top view. So for which you have to draw projectors from each of these cut points onto the respective top views of the slant edges. So from P dash I draw a projector to the slant edge OD, because P dash is on O dash D dash, therefore its top view P will be on OD. So from P dash I have drawn a projector to OD. So here you will be getting the cut point P. The top view of P is represented, so the top view of P dash is represented as P. Similarly Q dash, the cut point Q dash is on slant edge O dash C dash, therefore its top view small q will be on OC. So you need to draw a projector through Q dash and we get the cut point, the top view of the cut point Q. Next slant edge is R dash. So before locating the top view of R dash, let us locate S dash and T dash, because there is some difference in locating the top view of R dash. So before that we will locate the top view of S dash and T dash. So we draw projectors through S dash. Where is S dash? S dash is on O dash B dash. So we draw projector through S dash onto OB. You need to draw only up to AB, OB. So here you will be getting the cut point S. So S dash is on O dash B dash, therefore S is on OB. Similarly, T dash is on O dash A dash, therefore T will be on OA and on a projector through T dash. So from T dash I have drawn a projector to OA to locate the top view T. So we have located the top views of 4 cut points. There is one more cut point remaining, which is R dash. Now if you try to locate the top view of R dash, just as in the previous cases, you will not be able to locate it exactly, because when you draw a projector through R dash, here you can see that it will just pass through OE. Here the cut point R dash is on O dash E dash, therefore its top view will be on OE and on a projector through R dash. We know that the front and top views of a point will be always on a same projector. So R dash, if you try to locate R, you need to draw a projector through R dash onto OE. So when you draw a projector through R dash, you can see that it will just pass through OE. You will not be getting a single intersecting point. Now to solve this problem, what we do is we draw a horizontal line. We draw a horizontal line from R dash onto the slant edge O dash A dash. So that let's take this point as say 1 dash. So we get a new point on O dash A dash, which is named as 1 dash. Now where is 1 dash? 1 dash is on O dash A dash. Therefore the top view of 1 dash, which is 1, it will be on OA. So we draw a projector to locate 1 on OA. So from 1 dash we draw a projector onto OA to locate 1. So this is your 1. Now we rotate the point 1 with O as center and O1 as radius. We draw an arc with O center and O1 radius. We draw an arc onto the top view of the slant edge OE. So we are trying to locate the top view of R dash, which is on O dash E dash. So when you follow the normal procedure, we are not able to locate the point R, because when you draw the projector through R dash, it just passes through OE. To locate R dash, the top view of R dash, we draw a horizontal projector onto the slant edge O dash A dash, so that we get the point 1 dash. Now from 1 dash we draw a perpendicular projector to the slant edge OA and we get the point 1. Now with O center and O1 radius, you need to draw an arc onto the slant edge OE. Now we get, so this will be the point R. So this is how we locate the front view of the top view of R when it come across a problem like this. So you will be facing this problem whenever you have the front and top views of an object both perpendicular to XY line. So if you have a cut point on this point, say P dash, and if you try to locate its top view, you will not be getting the top view exactly. So we assume that it is on another slant edge, another non-slant edge. Say this be the top view of this slant edge. So we transfer this cut point onto the top view and we rotate to get the top view exactly. So this is the procedure that we have used here to locate the top view of R dash. Now we have located all the top view points. Now just join PQ, RS, PQ, RS is joined. Now this is the sectioned surface which you will see in the top view. So you need to draw hatching lines in order to identify this as the hatched surface. So initially when you draw, it should be drawn using light lines, and the portion which is from O to Q, OS, OT, OR and OP, those lines should be light lines, and only the remaining portion should be made dark. And in the front view also, the portion which is above this line should be light, and only the portion which is below this line should be made dark. Now here you are also asked to draw the sectional views. So we have completed the sectional views. This is the sectional top view and this is the sectional front view. Now you are also asked to draw the true shape of the section. Now what is the condition to see the true shape of the section? The lines of sight should be perpendicular to the section surface. That is the condition to get the true shape of the section. So here if you look from the top, you will not be able to see the true shape of the section because the lines of sight are not perpendicular to the sectioned surface. It is inclined to the sectioned surface. So to see the true shape of the section, we make the sectioned surface, only this surface, we will make it perpendicular to the direction of view. So this is the direction of view. We will make this surface perpendicular to the direction of view. So only this surface, that is P dash, Q dash, R dash, S dash, T dash, that line we redraw here, we make it parallel to XY line, and we mark all the points at with the same distance. P dash, Q dash here should be same here also. So P dash, Q dash, R dash, S dash and T dash. Now you need to draw projectors from each of these front view points, P dash, Q dash, R dash, S dash and T dash. Next, draw projectors from PQ, RST, from Q and S, from T, and then from P, from R. Now the projectors through P dash and P, the point of intersection of these two projectors will give you the cut point P1. The top view is named as P1. Similarly, Q dash, the projectors through Q dash and Q. Here you can mark Q1, then S dash and S, S1, T dash T, it is T1, and R dash R, R1. Now simply join these cut points. So this is the true shape of the section. So here you can see that in the sectional top view and true shape of the section, both will have approximately similar shape, but the true shape will be slightly larger than the sectional top view. And here also you need to draw the hatching lines in order to represent that this is a true shape of the sectioned surface or true shape of section. So this is solution to this problem. Now we will see one more problem. Now let us consider another question. Here the section plane is perpendicular to HP and inclined to VP, and the solid is a hexagonal pyramid of 25 mm base edge and height 55 mm. It is resting on HP on its base, with one base edge perpendicular to VP and is being cut by a section plane perpendicular to HP and inclined 45 degree to VP, and this section plane passes through the pyramid at a distance of 10 mm from the axis. And you have to draw the sectional views, and since the section plane is inclined to VP, you are also asked to draw the true shape of the section, because in the front view you cannot see the true shape of the section. You will be seeing an apparent shape. To see the true shape, you have to make the cut surface perpendicular to the direction of view. So first you have to draw the orthographic projections of the solid in the given position. Here the hexagonal pyramid is resting on its base on HP with one base edge perpendicular to VP. So when you make one base edge perpendicular to VP, automatically the opposite base edge will also become perpendicular to VP. And I have completed the front and top views of the object in the given position, and I have marked all the base corners and the apex in both front and top views. Now the next step we have to do is we need to introduce the section plane. It is given that the section plane is perpendicular to HP and 45 degree inclined to VP. So this is the position of the section plane. It is perpendicular to HP and 45 degree inclined to VP, and there is one more condition given. It should pass through a point which is 10 mm away from the axis. Now in order to exactly locate this position, first you have to draw a 10 mm radius circle with O as center. So with O as center, I draw a 10 mm radius circle. It should be a light line because this is a construction line. Now all the points on the periphery of the circle will be exactly 10 mm away from the top view of the axis. And it is given that the section plane is perpendicular to HP and 45 degree inclined to VP. Now you have to draw a line tangential to this circle at an angle of 45 degree to XY line. So we need to draw the section plane which is tangential to the circle. At the same time, it should be inclined to VP by 45 degree. So this angle should be 45 degree. So what we have done is, first we drawn a circle of 10 mm radius with O as center, and tangential to this circle we have drawn the section plane, the trace of the vertical plane at an angle of 45 degree. Now we need to identify the cut points. So this is section plane. It cuts two slant edges and two base edges. Which are the slant edges being cut by the section plane? OE and OF, and the base edges being cut by the section plane is DE and AF. Now we need to identify the cut points. So on the base edge DE, the cut point is, I mark the cut point as P. Next is a slant edge OE. Here I mark the cut point Q. Now there is another slant edge OF. Here the cut point is marked as R. Next is not a slant edge, it's a base edge AF. Here I mark the cut point S. Now two slant edges and two base edges. In total 4 edges are being cut by the section plane, and hence there are 4 cut points. Now we need to transfer these cut points onto the respective front views. So where is P? P is on the base edge DE, therefore its front view P dash will be on D dash E dash. So we draw a projector through D dash, we draw a projector through P to D dash E dash. So here D dash E dash appears to be a point in the front view, therefore P dash will also coincide with this point. So we mark P dash here, the front view of the cut point P. Next is Q. The cut point Q is on the slant edge OE, therefore its front view will be on the slant edge O dash E dash and on a projector through Q. So through Q I draw a projector onto the slant edge O dash E dash. So here I get the cut point Q dash. Next I need to locate the front view of R. So here again we will be facing a problem point because the slant edge OF and its front view O dash F dash both are perpendicular to XY line. So in such cases we will be facing a problem point just as in the previous problem. So here we will be doing the reverse. In the previous question what we did is we had the front view like this and the top view, both are perpendicular to XY line, and we had a cut point here, say P dash. So we assume that we transfer this cut point onto a known position and we draw a projector, then we rotate. So we have to do the reverse here, because here the known cut point is in the top view, which is R. So we have to start from here. In this problem, the problem point is here. We need to with OR center and OR radius, we need to draw an arc first, then draw a projector to the front view. So with OR center and OR radius, I draw an arc onto the slant edge OA. So I will be getting the point, say 1. Now from 1 I need to draw a projector to the slant edge O dash A dash. Then to locate the cut point in the front view, I need to draw a horizontal line parallel to the XY line. So I draw this line. So the front view of 1 is 1 dash, and when you draw the horizontal line you will be getting the cut point R dash. So this is how we solve this problem. We draw an arc with O center and OR radius to a known slant edge OA. We get the cut point 1. Now from 1 you need to draw a perpendicular projector to the front view of the slant edge O dash A dash. We get the cut point 1 dash. Now from 1 dash we draw a horizontal projector to get R dash. Now there is one more cut point S, which is on the base edge AF. So from S we draw a projector to the front view A dash F dash. So I get the cut point S dash. So this is S dash. Now you need to connect the cut points P dash, Q dash, R dash and S dash. So P dash, Q dash, Q dash, R dash and S dash. Now this is the cut surface, and now the remaining thing you need to make dark. So only the portion which is between the section plane and the observer is removed. The remaining portion is retained on the solid. So here in the top view you can see that this is the section plane and the observer is looking from this side. So the portion between the section plane and the observer is removed. So this much portion is retained on the solid. And the remaining portion should be retained as light lines. So here you can see that if you consider the slant edge OF, some portion of OS is cut and removed. So only the portion till OR is retained on the solid. So O dash R dash will be a dark line. Now there is another slant edge exactly at the back side, which is OC, which is not removed from the solid. Actually it is there, but it is at the back side. So a hidden line is represented like this. A line which is not visible or which is at the back side can be represented like this. So the remaining portion only you can represent in the front view. So the remaining portion of OC can be shown using invisible lines. So these are the sectional views, sectional top view and sectional front view. Now we need to draw the true shape of the section also. You are also asked to draw the true shape of the section. So here the section plane is not parallel to XY line, so make it parallel to XY line. So here PQRS is the line, so make it parallel to XY line. With exactly the same length, and mark all the points P, Q, R and S. Draw projectors and also draw projectors from the cut points in the front view. So already there is a projector connecting, passing through P dash and S dash, which is the X value in itself. Now P and P dash, the projectors through P and P dash, you will be getting P1 dash. Since it is a front view, you say dash, P1 dash. Then Q and Q dash, we get Q1 dash. R and R dash, we get R1 dash. S and S dash, which is S1 dash. Now simply connect all these cut points. Now this will be the true shape of the section. So this is how we draw the true shape of the section, and this is the solution to this problem. So the remaining topics we will see in the next session. Thank you.